thanks for coming, guys. Thanks for coming, guys. So this one is this topic is about microservices with Spring Cloud, Netflix OSS. So just about me, my name is Udhayakumar Rajendran, but shortly Uday, and I work as a software developer in Camlin Technologies. It's based out of Lisbon. So my day-to-day job, I do work on Spring Framework and Angular, so kind of a full stack there. So if you want to know more about me, then these are the links. So the agenda today is microservices. So we refresh about the basics, then we deal with a small use case, and then just go through some of the theory of what are all those components involving Spring Cloud, and the Netflix OSS, a demo, and then if possible questions. So in this session, try to cover these things. On the left, the configurations, service discovery, load balancing, circuit breaker, gateway routing, logging, tracing, a sidecar. So things I would not be able to cover. The security, event-driven microservices, build and release DevOps, DevSecOps, testing, and everything else. So other topics that we are going to be held today, or these are the other sessions, maybe the one that are already paused. So if you want to have more knowledge on the microservice testing, one coming up this evening, I guess, and one more is about an alternative to tracing or logging using Prometheus. So how many of you already develop or do something with microservices here? Okay, so then, okay. So based on that idea, I will just rush through all the theory and then make the demo in the last 10 minutes. So it's quite a lot, so I'll try to complete everything within 15 to 20 minutes, and then we will have a 5 minutes demo. Okay. So the microservices, so what is the reason for microservices? Like one of the main disadvantage of the monolith is where you have all the applications interacting with each other. Every systems communicate with each other with one big stack. That means one singular application. So you do not distribute the systems. It's all in one big box, and they communicate with one DB or many backend systems. So it was called, the scalability is a major issue in this one, and also lots of non-functional requirements. You will think about capacity planning and things like how scalable our architecture is. That is one of the big disadvantage of microservices, monolith. So moving on from monolith, we have something called SOA. It's a service-oriented architecture. From I think 2005 onwards, this was almost like microservices of 2005. So everyone was involved in developing a SOA product or SOA suite or whatever you call. So it's actually you distribute all the services, or else you construct services and make those services talk with each other, and then you bundle a middleware component in between those services. So service 1 could talk to service 2 going through a middleware, let's say an enterprise service bus. So there are lots of products like Mule ESB, Oracle Fusion Suite, and many products that came up with kind of a middleware solution. So that this works, this still gave you some kind of a control of what's going between the services. Compared to monolith, this is better architecture because you have your own service, and that service should communicate with the external services. Let's say for the insurance, you can communicate with the queue service or claim service, even the license service to check what's happening. For all those things, you will use an SOA, but you achieve loose coupling. But the disadvantage, you see the complex configurations, the transformers and adapters, and you will need to change from XML to JSON. You need to take the message, enrich it, and then you will split up the messages. You do a lot of enterprise integration patterns in SOA, so which over time becomes more and more complex. Then moving on from there, that's some microservices. It has a narrow scope. So here you have extract everything into a one small box. You construct a service which is in itself has very narrow scope. It does one thing and it does good. That's the concept of the microservices. So it's a fine-grained, mostly decoupled, but it has its own disadvantages. Operational complexity is the major disadvantage, and many other things which you will see due course. So this is the definition put forward by James Lewis and Martin Fowler, I think in 2015 or something, I don't know. But you see that these services are mainly, it should be independently deployable, fully automated deployment, centralized management, different programming languages, support different data storage. Another definition is put forward by Adrian Cockford. So they are nothing but a fine-grained SOA with a bounded context. The context of microservices is fine, I mean, it's already defined. You should not move further from what you're actually planned to do. I mean, if it's a claims service, it should stop at the claims. It should not have things of knowledge about policy, court, and every other things. So I'm talking about insurance because the use case is going to be the insurance. Oh, sorry, I think I should switch on. Okay. So these are the pros and cons. So microservices should be stateless, disposable easily, and then should be fine-grained, highly independent, scalability, resilient, fast deployment. I mean, you have lots of DevOps support for the microservices, and then it should be technology diversity. You have polyglot support in microservices. So the cons, you see the major disadvantages is operational complexity. Mainly it's DevOps heavy. Complexities in itself, it's inherent in the distributed systems. Transaction modeling is tough, joining and other distribution architecture is very tough, and then cost of server sprawl. Microservices is supposed to be scalability. I mean, you can keep on cloning the microservices, and then you will end up with lots of clusters and lots of instances, which will cost the server. It will end up in lots of server cost, and then the testing is a big difficulty, but we do have something like cloud contract testing and Spring Cloud Contract, the pact, lots of things coming up. And then the last one is the Conway's law. So it's a law about a kind of a hypothesis where Melvin Conway in 1960 put forward like organizations which design systems constrained to produce design. It basically means tightly coupled organizations will produce a tightly coupled system, loosely coupled organizations will prepare a loosely coupled system. So that could be an advantage or disadvantage, but mainly you cannot change the work culture of a organization, which is very tough. So you need to change that in order to be successful in microservices. So next. So enough of this microservices. Next we go to the actual topic. So what we are going to cover today is Spring Cloud, Netflix OSS, and the support provided by Spring Cloud and Netflix OSS to develop microservices. So what Spring Cloud does, actually it provides tools to develop common patterns for your distributed systems. It's actually helps you avoid boilerplate patterns. You need not implement those boilerplate patterns. It provides you lots of libraries to handle that, and then it would work in any environment which is cloud agnostic, and then it supports you. You can also do development locally, and it is not that you need to have a cloud system to develop a microservice. You can develop locally and test it in your local machine without any cloud support. So we are going to cover these things mostly. This is the mapping between the Spring Cloud and the Netflix, or what are the libraries or the components that we are going to use. So the left side discusses about the components you will need to develop microservices. On the right side you will see the Netflix support, Netflix library or the Spring library or anything else. Let's say configuration server. Here you have Spring Cloud config server. That's the library. If you don't want to use it, then you will use something like console or else a vault. And then service discovery, it's going to be Netflix Eureka, or else you can use Zookeeper console. Load balancer, you will use Netflix Ribbon. For circuit breaker, you will use Netflix Hystrix. Gateway, Netflix Zool. And then the latest one is the reactive gateway from Spring Cloud. So it's a Spring Cloud reactive gateway. For logging and tracing, you use a library called Spring Cloud Sleuth, and then you can use tracing via Zipkin, ELK, and other things. The message and event driven, It's like for event-driven microservices, you use a library called Spring Cloud NetStream. For security, you have Cloud Security, which supports JSON Web Tokens and OAuth 2. For polyglot support, you have Netflix Sidecar. So this is an overview of the support provided by Spring Cloud, Netflix OSS, to develop your own components. Next, let's move on to the use case. So this is a use case which we will discuss today. It's an insurance company. Let's say there is a NI Mono Insurance. It's a Giant's Causeway. You see a big monolith application interacting with lots of backend, and you see there is no composability, and the scalability will be a major issue here. And so every time you need to change one particular component, you will need to down the system and then deploy it again to make the system up. So which is not friendly, or it's not profitable. Let's go to the SOA. So this in insurance, you have migrated to the SOA system where you have a middleware which is an ESB or something. You have lots of services, and the business process are defined in the top. Let's say these are the process for the insurance limited. So from monolith, we pass on to the SOA, like codes, rating, policies, and billing, claims. So all of these systems, all of these business process will interact to the backend systems through a set of services, but you could see all these services are interacting with each other in lots of spans. And then you will also need to deal with quite a lot of adapters and changing message format from one thing, XML to JSON, or lots of other stuff. So finally, we come to the fine-grained solution where you separate out everything. So policy, code, rating, billing, claims, telematics. So these are the basic fundamentals of the insurance industry. So in our use case, we are going to talk about an insurance use case. So, but how do we actually develop this? So this is a 12-factor app. So this will give a basic guideline of what we are going to do and how we are going to build a microservice. So if you are not already aware, so these are kind of 12 factors put forward by, I think, Twitter or someone, but I'm not sure. But so you have a single code base, then should have a dependencies. There should be a configuration management, build, release, processes, port binding, concurrency, disposability. Basically, this means it's all about non-functional requirements. Microservices helps you achieve the non-functional requirements very easily, and then it's more and more tied towards the non-functional requirements compared to the business requirements. Developers can concentrate on the business use case. At the same time, they will also take care of the non-functional requirements instead of leaving it to someone else. So now this is what we will achieve. This is what the demo I'm going to show you, but this is the one that we are going to discuss now. REST UI in the top, and then there are 3 services where I have code service, a rating service, a sidecar which we'll call the policy service, and then for the tracing or login we'll use a Zipkin and a ELK stack. How many of you have used ELK here? Elastic Log Stash. Okay. So this is ELK is nothing but it will help you analyze the logs. Visual Kibana will help you visually analyze your logs, what's going on between those logs. It will provide you some kind of analytics. Zipkin is used to trace what's happening between all those services. I mean, if you want to trace the span or trace what's happening between one service and the other service, you'll use a program called Zipkin. And okay, we'll just now we'll just rush through all the libraries, just the basics of all of these things. So Spring Cloud Config, it helps you provide a centralized store accessible across the microsystems. So the integration, you could have a Spring Cloud Config provides you integration with Git, SVN, Console or Vault, and also file system. The retrieved configuration details from config server on the startup. Actually, Spring Cloud Config is nothing but you have a configuration system which will contain all your configuration properties isolated from the microservices. So you develop a separate config server, or what you call a config service, which will contain all the properties that your services will be using, the downstream services will be using from that. So this is an example. There is a Git on top, but you could also have Console or Vault or whatever you want. So and then the config server will fetch the details. If you have if your properties are pushed to the Git, it will have a local cache, and then the config server will always have the local cache from the main system. It could be Git, it could even be your local file system, and all the downstream services will get the configuration properties from the config server. The main thing in the properties, like you will need to provide the password for database connection and any other backend system connections. So those passwords should not be in the plain text. You can encrypt them with a symmetric or asymmetric. Like symmetric is a shared key concept, where you have a key shared between all the microservices, and that key will, the property will be encrypted with that key. Asymmetric is a public private key methodology, but you can use Vault service, which is even better than these things. So Vault is provided by HashiCorp. And then the microservice clients do not start up on boot up. So if the config server is down, your microservices will not fail. It will still try to start up, but it could not use the Spring Cloud config. It could not find the config, and it will eventually drop out all the requests. So next is service discovery. It enables microservices to discover with each other, abstracts the physical location, the server and client. Here the client heartbeats, so every client will register itself with the microservices, and then there is also support provided by load balancing. If you need to do inter-service communication, you have the service discovery client, 3 options where you have Netflix Feign or OpenFeign client, and the latest stuff is the Spring Web client. It's an alternative to Netflix Feign. So it's a reactive non-blocking stuff. Other alternatives, like I said, it's Zookeeper console. So this is a sample of the Eureka dashboard, so where you will find all the instances registered with the Eureka. So your microservices get registered to the Eureka centralized service discovery server, and from there you can map your services and access the services. So one of the use case of Ribbon is a load balancer. It's a client-side load balancer. Suppose if your sidecar service is down, then the Ribbon will notify Eureka server and it will be removed. So no more requests should be going from the sidecar to the Eureka. So load balancing is provided by something called Netflix Ribbon. It's a client-side IPC, inter-process communication library. So actually it's useful in the remote procedure calls. Provides good integration with the service discovery, that's in Eureka. Lots of load balancing rules like round robin, weighted response, a lot of things. Provides a fault tolerance. One of the main thing is it doesn't call the Eureka every time. It catches the location of the services locally and checks periodically with the Eureka. That's how it deals with the load balancing. So resiliency is one of the important factor in microservices. You need to fail fast. So there are 3 different resiliency patterns: circuit breaker, fallback, and bulkhead. So Netflix Hystrix provide that kind of a resilient pattern. So this is from Martin Fowler. So if you see the client and the supplier, the circuit breaker is in between. In the first case, you see the supplier could not, this is a connection problem. The client could not get the response back from the supplier. So you need to have a circuit breaker in between, which will trip that and then send you proper response. It could also time out, and then the trips in between, that's the circuit breaker, could have a fallback mechanisms. So this is how you do it, like enable circuit breaker on Spring Boot, some history command. So usually 1000 milliseconds is the default timeout. If your response fails to come back within 1 second, then it fails. So you can change those properties. You can modify timeout and other properties through the Hystrix property. There's quite a lot of properties. You can modify that. So fallback processing uses the Hystrix command fallback method. The next one is the thread context. You have the lots of isolation models like thread and semaphores. Quite an intensive topic, so just skip through that one. So this is an example of how you will analyze the circuit breaking. So the Hystrix dashboard. This is a Netflix example. So Netflix API Hystrix monitoring, where you have lots of video and lots of services. What's happening when one service is down, and how this Netflix Hystrix circuit breaking is handled in Netflix. Next thing is Zool. I think it's some of the stuff not visible, but okay. Netflix Zool is provides authentication, testing, dynamic routing, service migration, stuff like security, throttling, and other stuff. So Netflix Zool is actually a gateway service, so it provides a policy enforcement point and cross-cutting concerns. So Zool server will actually provide you like it's an API's request server, so which will provide a policy enforcement, cross-cutting like logging, security, and everything else. So it automatically uses Eureka to look up any services registered with Eureka, and then it will act as it's actually a reverse proxy sitting in front of Eureka. So whenever your request goes through the Netflix Zool, it will be interpreted as a request coming from the Netflix Zool itself. The downstream will not have any idea about the actual origin of the actual origin of the request. So it also provides lots of filters like pre-filter, post-filter, route filters. Route filter, for example, you can do the A/B testing pre and post. The pre-filter, you can inject something in the request. Let's say you can inject a correlation ID, which will be useful to trace the microservice flow. The alternative to Netflix Zool, Spring Cloud Gateway, which is available from Spring Boot 2 onwards. It's designed on Spring Framework 5. It's a reactive non-blocking gateway. And finally, we have achieved this structure with all these libraries. So here, all of these are a Spring Boot service. The policy service is a Go service. It's just a simple Go service, but which is a polyglot. It's a non-JVM. And you have a sidecar, so we'll discuss what's that. So polyglot service provided by Netflix Sidecar. So this is a library that will help you to write code in Node.js or Go or whatever external Ruby or whatever external language. And with this, you can use Spring Cloud to interact with these services. So it is based on thing called Netflix Prana. It's mainly used to harness other Netflix libraries. So the Netflix Sidecar, it contains embedded Zool proxy. It also can communicate with the Eureka and its own ribbon. So how you actually do it is use something called Sidecar Health URI, which will emit the status of that your services that you write in Node.js or Go. The external services should emit a status up or status down. So that's the health status. If it is status up, it means the status. It means the service that the external polyglot service is up, and the sidecar will indicate to the Eureka and upwards, like in Zool, that this service is accessible. One of the main point you need to note is sidecar service should be run on the same host. You cannot run it on the different host. So wherever your other microservices are there, you need to run the sidecar service on the same host as the non-JVM app. Next, logging or tracing. So use this is a Spring Cloud Sleuth. So you see how the request goes. Actually, this is the one. There are lots of spans going on between. So one microservice, one request from A will contain B, lots of like a tree structure. So these are the spans, and the top is the parent of the tree, which is called trace. We'll see all of these in the demo. And in order to trace the services, you will have a Zipkin, so which will allow you to trace. And then so finally demo. So before we go to the demo, it's a release train, which currently we are using Spring Cloud. You need not get each and every libraries separately. You use a release train. Currently we are on Finchley. So the demo I'm going to show you is on Finchley. So it's an Angel. It's based on the London Tube. So it's a bill of materials where it's a curated list of libraries provided by Spring Cloud. So currently we are on the Finchley. It's named alphabetically. And this is the reactive. So one of my microservice uses the reactive framework. It's a Spring Framework 5 and Spring Boot 2. So this is it uses something called Spring WebFlex. So there is no blocking. It's asynchronous and reactive microservice. Oh, this is the use case that we are going to see. I have a quote, I have a quote service, and then I have a rating service. The quote service will contain a quote with a risk, with lots of risk details. And the rating is in MongoDB. This one is in MariaDB. And we'll just go through the demo and find out what's happening. So now I'll show the demo. So I haven't Dockerized anything, so I'm going to show the demo from my workspace. So if you see, these are the instances that I'm running: config server, Eureka, code service, rating service, sidecar, and Zool service. Everything is up. And my Go service is here. It's running on IntelliJ IDEA. So it's a very simple service. So I'll just explain what's that. So in the config service, what you will actually have here is like you will have all the resources configurations. So you have the bootstrap YAML, like you will see the So you'll see this is the config server. I'm using a local config server. So I'm using the search locations from my local file, but you can also use the Git. So where you'll have the config server from Git configuration. So it's a native. If you are using Git, you'll change that one accordingly. And next one, I will show you the Eureka server. The Eureka server configuration will be like, so it runs on the port 8761. The client registers with Eureka. No, because this is the Eureka server, the clients need not register with Eureka. The fetch registry is false. These are the management endpoints, which I will show you shortly. And this is an example of your actual microservice. Let's see what is there within this application YAML. So again, you provide the server port. You will register with Eureka. I'm using prefer IP address. And then the register with Eureka is true, fetch registry true on the default zone where it will interact with Eureka. And I'm using logback for logstash. Similarly, for rating service, I have kind of a similar configuration here. You will see this is the main thing to note here: register with Eureka true, which means this will make the microservice as a client. Let's see what are the libraries that I use for the microservice. I'm using Gradle. So Spring Boot version 2, it's my code service. I'm using a Spring Cloud version, that's the release train which provides the bill of materials. So these are I'm using a starter config and the webflex. I'm using both web and the webflex on the code service because the code service isn't reactive. And other stuff like Eureka client, OpenFind, and quite a lot of other things. So finally, the other stuff is the rating service, which uses the MongoDB, and then the Zool server. The Zool, we use the default port 555. And even Zool will register itself as a client to the Eureka. And these are the Zool properties. You prefix Zool with API, code service, rate, and then policy service. So I'm running out of time, so I'm rushing up. So let's see the demo, what happens. So these are my instances registered with Eureka. So code service, rating service, sidecar, and then the Zool server. So if you open it, it will provide you. So this is the actuator endpoints. This will provide you lots of health information. And this refresh is used if you want to change the configuration in runtime, real time. We'll use this one. Okay, and this stuff here is the routes defined on the. These are the routes defined through the Zool. So this is an example of accessing rating service through Zool. Zool is provided via port 5555, and I am accessing my rate service with API/rate/ratings. And this is code service via multiple codes. So let's deal with a simple use case. So this is an example of I'm using a postman to get the default properties This is my MongoDB URL. It's in the config server. And if I want to get a particular quote, I use quote 1. Let's see what happens with posting a particular request. So I access a quote and post that using post method on the quote service. So there are few stuff, exception. So this is a post method that I will, so this is successful. Now you see that this is my table and I have the latest quote. So this rate is coming from the external service, that is a policy service. So this is the MongoDB. I'm using a cluster online. So I think it's time to wrap up, but so quite a lot of other things to show. Maybe we could just wind up with the Zipkin. So this is a Zipkin which I'm running on top of Docker. So you will see the traces here. So the latest service has failed for some reasons, and we'll see the latest newest first. So the newest one is a success. So here you see the span on top. So my post quotes, the Hystrix and the ratings, everything is here. So this is the origin, and if you want to drill through, you can see that one, or you can see a JSON response as well. Okay, so here you will find all the span IDs and the trace IDs. Actually, it should allow me to drill through, but I don't know what's happening. So this is how you do the tracing, where you will find what is the origin of this microservice and where it ended up communicating with any other external microservices. So you can find the entire trace of the microservice. I just wrap up here. So these are the references, and finally, so these are the references, most of the stuff in Cloud Spring IO, and then the Martin Fowler. So it's fast moving. Many of the tutorials and references that you will find online, it's already outdated. You use the Cloud Spring IO for that. And finally, thank you. If you need more information, I could not handle a Q&A, but if you have anything to know about, just mail me or put on the Twitter. So that's it, I think.